Hello, Year 5. I hope you've had a lovely half term. I hope you had a lovely week to rest and recuperate and get ready for a new term. This will be the first time I'm talking to you on video for our new term, because yesterday, hopefully you did a little quiz online to show us how confident you are with your time skills. So I hope you're ready today for some new maths learning. So I'll just share my screen with you so you can see what we are doing. First of all, I wanted to just briefly talk to you about your times tables. So remember, that's something we want to keep practicing, keep it fresh in our minds. So well done to these people over the last 2 weeks. They put the most minutes in on Times Table Rockstars. So that's Alfie, Finley, Harry Meredith, Ollie and Will. Well done you, you're our top 5. And last term we focused on these times tables, so 6s, 7s, 8s and 9s. And so this week your garage level is going to be set to all 4 of those times tables to help you just remember those from last term before we move on to focusing on a different one. Obviously the other levels on Times Table Rockstars will test you on anything up to 12 times table. But if you go on Garage, it will specifically test you on these ones. So you'll be able to see if there's any that you really need to keep practicing and working hard on in your own time. Okay, so we are starting to look at something new over the next few maths lessons. And it's a part of the measurement topic in maths. So I just wanted to start with looking at measurement in general and looking at the different vocabulary we might use when we're talking about measurement. So I've put a bunch of different words on the screen for you that all link with measurement in some way. And what I want you to do to begin with is not to write anything down, but to spend some time having a little think to yourself, or perhaps talking to somebody else if there's somebody with you, about the language that I've put on there. And I want you to think about a few things. I want you to think, do you know what that word relates to? What sort of measurement is it talking about? Do you know what units you would use when you're measuring something using that vocabulary? What is it measured in? And would you feel confident using that type of measurement? Okay, so the 3 things I've asked you to think about are, do you know what that means? What type of measurement is it? Do you know what you would measure it in? What units of measure you would use? And do you feel confident using that particular skill? Okay, so pause the video, have some time to think or talk to somebody else. Okay, so hopefully you've had a chance to have a think or a talk about that vocabulary, and I just want to run through some of them with you so that we kind of all understand where they fit before we move on to looking at more specifically at one type of measurement. So I've grouped some of them together because I felt like they sort of fit in the same category. So here I've got the vocabulary that I thought linked well with talking about distance. So we've got length, width, which is also described as breadth. So if you see breadth, it's a similar idea. Height and depth. Okay, so all of those are to do with the distance from one point to another. So that might be, you might be talking about quite a long distance, like the journey from one place to another by car, or you might be talking about quite a short distance, so measuring something in centimeters. You might be talking about shapes, so sort of the length or the distance around the outside of those shapes, or you might be measuring one single line. You can see here, I've got a 2D shape where I can measure the width and the length, or a 3D shape where I've got that extra dimension, I'm measuring the depth of that shape as well. Some other measurement vocabulary that would fit well with this would be perimeter and area, which we've looked at before in Year 5 already. So perimeter, the distance around the outside of the shape, and area, the amount of space that shape covers, looking at 2D shapes. And then the units of measure we might use would be millimeters, centimeters, meters, kilometers, inches, feet, yards and miles. So these ones along the top here are what we call metric measurements. You'll see them more often. These ones along the bottom are what we call imperial measurements, so kind of older language for measurements that people sometimes use in different situations. So that language there was all about length or distance, okay, which we will come to later in Year 5. And then I've grouped these two together, mass and weight, okay? So again, this is a different type of measure where we're looking at often how heavy something is. And I've put some weighing scales here that you might use to measure this. And you might come across the word mass, but you might be more likely to have heard the word weight being used either in your lessons or kind of just generally in conversation. And they're actually two different things. I'm not going to go into depth about it because that's not what our lesson's about. But mass really is kind of the stuff that makes something up. So my mass, like this person here, is the kind of the solid measurement of me, okay? And then the weight, even though we talk about weight as being kind of like how much stuff there is to me, if I was to put myself on weighing scales, what would my weight be? Actually, what weight really means is about how much of the force of gravity is acting on you. So scientifically, they are quite different, but we use them quite similarly. And we might use milligrams, grams, or kilograms. They would be the most common metric measurements we'd use for mass or weight. And then we've got our imperial measurements, ounces, pounds, and stones, which you might also hear. And weight, if we're being scientific, weight is actually measured in newtons because that's a measurement of the force of gravity on something. But don't worry about that if that's a little bit complicated. Basically, those words are talking about kind of how heavy something is, which is again something we'll look at later in the year. I've then put capacity and volume together, which are two different things, but they are slightly different, and we are going to be looking at those in the next few lessons. Okay, so we'll talk more about this, but essentially capacity is the amount of liquid a container can hold. So you might measure the capacity of, I don't know, a milk carton like we've got on the screen, or any sort of container. So the capacity of something, you might say it's the capacity of that pot is 1 litre. Whereas volume is how much space an object takes up. So if I had some liquid in my container, then I could say, well, what's the volume of that liquid? If I had, I don't know, any object, I could say, what's the volume of this object? So a 3D object or a liquid or a gas, how much space is it taking up? Okay, so capacity is how much can I fit in? Volume is how much space is that thing actually taking up. And the last few I just kind of put on here because they are ways of measuring things that you have done before, but they don't really fit with any of the others. So we've got angles, which is a measure of turn. So how far is something turned? We measure it in degrees. Time, which lots of different ways of measuring time: seconds, minutes, hours, days, weeks, months, years. You could keep going, decades. Whatever. So we will come on to time at some point. Money, obviously we measure in pounds and pence, and temperature, which we measure in degrees Celsius and degrees Fahrenheit. So that's just a bit of an overview of kind of the different types of measurement. And some of these we've already looked at. We looked at temperature when we were looking at negative numbers. You've looked at area and you've looked at perimeter already, just before Christmas. And I think that's all of them. So the ones we're going to focus on over the next couple of lessons are volume and a little bit of capacity, okay, because they do kind of link with each other. And then those other areas we'll kind of come on to later in the year. So today's learning objective is to understand volume as a measurement. So we've talked about measurement generally. We're going to look more specifically at the measurement of volume. So in your books, I'd love for you to write the learning objective and today's date, which if you're doing this on the day it says to on the timetable will be the 24th of February, 2021. So you can write that neatly in your maths book and underline it so that we know what you're learning about today. So we just want to understand volume as a measurement. Our signs of success are to know that volume is a measurement of 3-dimensional space. So it measures not 2-dimensional shapes that I've drawn on a page, but a 3-dimensional space, how much something takes up. We also are going to be counting cubes to find the volume of a 3D shape. And we're going to be writing measurements of volume in centimetres cubed as well. So that's what we're looking to do today. If you need to pause to carry on writing your LO and date, you can do now and press play again when you're ready. If not, then you are fine to keep going with me. Okay, well done, Year 5. So let's start off talking about volume. So we briefly talked about it earlier when we were talking about vocabulary. And I just wanted to point out that volume in music is different to volume in maths. Same word, two different meanings. Okay, obviously volume in music is about how loud a sound is. Volume in maths is a measurement of the amount of space an object or liquid or gas takes up. Okay, how much space does it take up? So we're looking at 3D things here, 3D objects, 3D shapes, 3D liquids, whatever. So things that exist in 3 dimensions. So we're not looking at 2-dimensional shapes. When we're looking at the space taken up by a 2-dimensional shape, that's measuring the area, which we've done before. When I'm looking at a 3-dimensional shape, so an object in real life, I'm measuring its volume, okay? So that's the difference between those two. Area measures how much space a 2D shape takes up. Volume measures how much space a 3D shape takes up. So to start off measuring volume, we're going to measure the volume of some shapes by counting how many cubes of space they take up, okay? So that's how we're going to start off looking at volume. So if you look at the picture there, you can see I've got 1 cube. And then if my shape is made up of 3 cubes, I'd say its volume is 3 cubes. Okay, so that's just a simple way to start off. It's not an accurate way of measuring volume, but it's the way we're going to start off and ease ourselves into it. Okay, so we'll be looking at how many cubes of space a shape takes up. Okay, so step 1, we're starting really simple. How many cubes are needed to create these 3D shapes? Okay, so you can pause the video in a moment, write down your question, which question you're answering, and write down for me how many cubes are being used to make these 3D shapes. Press play again when you're ready to check. Okay, so we'll check our answers for these, really straightforward. We're looking at the volume of these 3D shapes that we can see pictures of on the board. We're thinking how many cubes have been used to make each one, and we're going to say that's the volume of that shape. So 1A was made of 5 cubes, 1B was made of 3 cubes, 1C was made of 4 cubes, 1D was made of 5 cubes, and 1E was made of 7 cubes. So well done, I hope you're feeling confident with your step 1 of just counting the cubes to say what the volume of the shapes are. Let's move on then. So we've actually got one more question for step 1. And this question is going to take a bit of reasoning. So we're still thinking about cubes and how many cubes of space that shape is taking up. But I want you to do a bit of reasoning and kind of explain what you think. So this is question 1F. And this is Teddy, our friend Teddy. He says the volume of this shape is 7 cubes. Have a look at that shape and think, do you agree or disagree with Teddy? The volume of this shape is 7 cubes. Have a look, see if you agree or disagree. And then I'm going to ask you to pause the video and write your answer. I agree with Teddy because, or I disagree with Teddy because, okay? So look at the shape, decide what you think, and then write your sentence. I agree with Teddy because, or I disagree with Teddy because. Pause the video and press play when you're ready for us to discuss that one. Okay, so let's talk about Teddy. Teddy says the volume of this shape is 7 cubes. Now, I can see why Teddy might think that. I'm looking at the picture and thinking, well, there's 1, 2, 3, 4, 5, 6, 7 cubes that I can see. However, I wonder if there's a cube that I can't see making up this shape. I'm wondering if there's a cube here behind this cube here. So I'm thinking maybe there's a row of 2 here, a row of 2 here, a row of 2 here, but also that perhaps this is also a row of 2, and I just can't see the cube behind. So when we're thinking about how many cubes make up a shape, when I'm thinking about its volume, I need to think about whether there are any hidden cubes. Are there any cubes hiding behind that I can't see based on this picture? So the volume of this shape could be 7 cubes if perhaps there wasn't a cube behind, but I think it's quite likely that the volume is actually 8 cubes, and there's a cube underneath here completing this row. I wonder what you thought. I wonder whether you agreed with me or whether you thought there might just be 7 cubes. So as we carry on through our lesson, I want you to think about, can I see all of the cubes in this shape? Okay, what are the cubes that perhaps are hiding that I can't see? Right, we're going to move on to the next challenge, thinking about volume now. So if you weren't quite sure about the counting cubes part, you might want to go back and look at that. But if you're ready to move on, then move on with me. So remember, volume is a measurement of the amount of space an object or liquid takes up. Now, we can just count cubes. If we've got a shape that's made of cubes, we can say it's this many cubes, that's its volume. But if we know the measurement of those cubes, we can use that to help us measure the volume more accurately. So volume can be measured in centimetres cubed or in metres cubed. Have a look at the way that I've shown that. Centimetres cubed with my cube sign, which is a little floating 3. Or metres cubed, or I suppose you could say kilometres cubed, or any other length measurement that's been cubed. What other areas of maths does this remind you of? So have a little think. What other parts of maths does this cube, centimetres cubed, remind you of? Okay. Well, I was thinking about this and I thought it reminds me of area, because area I measure in centimetres squared, not centimetres cubed, but centimetres squared. Now you can see here, area is when I'm measuring how much space a 2D shape takes up. So its length and its width, I multiply its length and its width together. When I'm looking at 3D shapes to measure volume, there are 3 dimensions instead of 2. So can you see why I might have my floating 3 instead of my floating 2? I'm not just thinking about the length and the width, I'm thinking about the length and the width and the depth as well. There are 3 dimensions to think about. So that's why I'm looking at centimetres cubed. Here's my cubic centimetre. It's 1 centimetre by 1 centimetre by 1 centimetre. It also reminded me of my cube numbers, where I multiply a number by itself 3 times. And I can show that like this. 5 cubed is 125. Okay, there's my floating 3 again. So it links with those other 2 areas of maths. So let's have a look. If I know that each of my cubes measures 1 centimetre by 1 centimetre by 1 centimetre, so it's 1 centimetre cubed, I can calculate the volume of these shapes in centimetres cubed. So if I know that this cube here measures 1 centimetre, ooh, interesting writing, Mrs. Hardy, by 1 centimetre, and I know it also is 1 centimetre deep, then I can say, well, that is 1 centimetre cubed. And then I can do what I just did earlier in step 1, count up the cubes, and I know what my volume is in centimetres cubed. Okay, so I've got 1, 2, 3, 4, 5, 6, 7 cubes. Each of them is 1 centimetre cubed. So I've got my volume is 7 centimetres cubed. Excuse my writing on the board today. I can't write with my board pen because I'm using my mouse. Okay, so if I was to look at this shape, can you see why that would be more challenging to work out the volume of than my first shape? My first shape, I could easily see that there were 7 cubes. So I knew they were 1 centimetre cubed each. So I'm saying that the volume is 7 centimetres cubed. This shape is going to be a little bit more challenging because I can't actually see all of the cubes that make up this cuboid. I can see the ones along here and the ones along the top, but there are some on the second layer that I can't see. So what I'm going to do is I'm going to think about how many rows of cubes there are and use my multiplication skills to help me. So I can see that this shape is 2 cubes high. Okay, it's 2 centimetres cubed high. I can also see that it is 1, 2, 3, 4, 5, 6, 7 rows of cubes deep or wide, whichever way you want to think about it, okay? So I've got two cubes multiplied by 1, 2, 3, 4, 5, 6, 7. So I can see, and I can see that it's 4 wide, okay? So I've got 2 by 4 by 7. So what I could do is I could do 2 times 4 and then times that by 7. And that would tell me how many cubes there are. I could also just think about each row or each, what word am I trying to think of? Each level of my shape, I suppose. So I could think, well, I know that there's 1, 2, 3, 4, 5, 6, 7, 8 here. And then there's 1, 2, 3, 4, 5, 6, 7, lots of that. So I could do 8 times 7. So I'm going to use my multiplication skills to help me with this one, instead of just trying to count all the cubes and thinking about the ones that are hidden. So I'm going to start by thinking, well, there's 8 here, and I've got 7 lots of 8. Okay, so here's 1 lot of 8, 2 lots, 3 lots, 4 lots, 5 lots, 6 lots, 7 lots. Terrible drawing. So 7 lots of 8 cubes. So 7 times 8 is 56. So I know my volume will be 56 centimeters cubed. Okay. So when I can easily count them, it's very straightforward, and I know it measures 1 centimeter because it tells me. Or I could measure it myself, I suppose, if it was a real object I had in front of me. And here I've used my multiplication skills to help me work out how many rows there are of cubes. Okay, so 56 centimeters cubed would be my volume. Okay, we're going to have a go at step 2 now, which is that next level. So at the top, can you see here it says these shapes are built out of 1 centimeter cube. So we're telling you each of these cubes measures 1 centimeter wide, long and deep. Okay, each one of these is 1 centimeter cubed. What is the volume of each shape? So on this shape and this shape, it should be fairly straightforward because you can see all of the cubes, you can count them easily, and you can tell me what the volume will be in centimeters cubed. Remember that floating 3 after cm. Then the second part of your step 2 says these shapes have been drawn on isometric paper. That means they're drawn on not squared paper, but dotted paper, which makes it a lot easier to draw 3D shapes because you can draw diagonal lines to show the depth. If they were built out of 1 centimeter cubes, what would their volume be? So for this second set of shapes, it's that extra challenge like we just did earlier, where we've got to think about, well, what are the hidden cubes? So instead of counting every single cube like we can here, we have to think, well, how many rows of how many? So here I know I've got 2 by 2, and there's 2 lots of that. So I can think 1, 2, 3, 4. Okay, how many on the next part? Same here. I can use my multiplication skills to think, well, I've got 2 down, 3 across here, and then 3 back. So 2 times 3, and then times it by 3 again. So here we can count them, and here we need to use our multiplication skills to think how many cubes there are going to be in that shape. Each of them measures 1 centimeter cubed, so you can tell me what the volume is. So if you're ready, you can press pause and have a go at those questions in your maths book, just writing what the volume is of each shape, making sure you've written the question number. If you're still not sure about any of that, you could rewind and just watch my explanation, my example that I did before. Have a go and press play again when you're ready for us to go through those answers. Okay, welcome back, Year 5. Well done for having a go at those. So I'm hoping that 2A and 2B were fairly straightforward for you. So here's our answers here. So there are 10 cubes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We know each one of them is 1 centimeter. So my volume of my shape is 10 centimeters cubed. For 2B, I know there are 6 cubes. I can see them all, and each measures 1 centimeter. So my volume is 6 centimeters cubed. For 2C, my volume is 8 centimeters cubed. I know I've got 1, 2, 3, 4 cubes here, and so I must have 4 cubes on the next part, okay? So I've got 8 cubes altogether, and they measure 1 centimeter cubed each. So my volume is 8 centimeters cubed. For 2D, I can see that my shape is 2 by 3 by 3. Okay, so this part here, these cubes there are 6 of them. And then I've got 3 lots of that. 6 times 3 is 18. 18 centimeters cubed is my volume. And then on this one, I'll just start with this end here. I've got 4 by 2, which makes 8. And then I've got 2 more of those, 3 lots of 8. 8 times 3 is 24. My volume is 24 centimeters cubed. Have a look at your answers. Think about how confident you were with that. If you think you've got a different answer to me, have a think about why that might be. Perhaps watch the explanation back and see if that helps you. Of course, if there's anything you're stuck on, you can send us a message on Dojo and we can try and help you. Okay, Year 5, well done for everything you've done so far. This is the final challenge and it's your step 3. And I've got a guy called Ron here. Ron is making 3D shapes using 10 cubes. There are his 10 cubes, lovely blue cubes. And the question says, what different shapes could he make out of his 10 cubes? And will his shapes have different volumes? So if he puts his 10 cubes together in one way and then makes a different shape using the same 10 cubes, will the shapes have different volumes because they look different? And it's asking you to explain your reasoning. Now, you've got some options here, depending on whether you're at home, whether you're at school, whether you've got a printer, whether you haven't. So if you have a printer, you could print out the isometric paper, that dotted paper that I mentioned earlier. That's on your home learning timetable this week. So you might have already printed it out, or you could print it out. And on that isometric paper, you could draw the different shapes you think Ron could make using his 10 cubes. You'd have to use a ruler to do that. Let me just show you what that looks like. So you can see here, they've joined these dots, 1, 2, 3 dots along like that with a ruler. They've joined these dots up and along. So you join the dots to make your shape, okay? So you could have a go if you want to print out that isometric paper, have a go at drawing some 3D shapes using 10 cubes. Another option, if you don't have a printer, or perhaps if you do have something you can use to build the shapes, you could have a go at making some different shapes out of 10 cubes. If you've got some cubes at home, I don't know, perhaps there's some sugar cubes that maybe somebody at home doesn't mind you using, or maybe you've got some cubed kind of building equipment. I was thinking of Lego, but those are usually cuboids, aren't they? But if you've got some cube-shaped Lego, you could make some shapes out of 10 cubes. So have a go at making as many different types of shapes as you can. If you don't have a printer to print out your isometric paper and you don't have any cubes to make any shapes, you could instead just have a think about those questions. So what different shapes could he make? Maybe you could try and visualize them. And definitely think about that last question. Will his shapes have different volumes? Explain your reasoning. So you could just think about what different shapes he could make and then answer that question. Will the different shapes he makes have different volumes? Explain how you know, okay? So yes, I think they would have different volumes because, or no, I don't think they would have different volumes because. Try and use that explanation of what volume is to help you. So you've got options there. Either draw some different shapes with 10 cubes on isometric paper, use some cubes to build those shapes. So if you're in school, maybe you could use some multi-link to do that. Or if you're at home, see what you've got. Or you don't need to do either. You can have a think about the questions and write your answer to this question here. Will his shapes have different volumes? Explain your reasoning. So I'll just underline that one for you because that's the key one that I'd like to see your answer to. Will his shapes have different volumes? Explain your reasoning. So you can press pause now and have a go at whichever part of that you'd like to try, and then press play again and we'll just review what we've learned together. Okay, well done Year 5. Great effort today. I'm sure you've been working hard and really thinking about our learning objective, which was to understand volume as a measurement. So just want you to reflect on how you feel about today's learning. Do you feel like you've met your signs of success? So do you know what volume is a measurement of? Do you know the difference? Oh, I've changed my my signs of success on this slide. We'll get rid of that because that's for a different lesson. So were you able to count cubes to find the volume of a 3D shape? And were you able to write measurements of volume in centimetres cubed? And what I'd like you to think is whether you could finish that sentence off. What is volume a measurement of? Volume is a measurement of, you might want to write that sentence, or you might want to tell somebody near you. I want to see if you can actually explain what volume is a measurement of. Have a go at that now. So my example is volume is a measurement of the amount of space an object or a liquid takes up. I wonder if you said something similar. Well done, Year 5. Great maths work today. Please do share what you've done on Class Dojo so we can see. If you've got any questions, either get your adults to send us a private message or put a question on your Dojo portfolio. I'm using the text tool, or I'm not sure, it might be called different things on different devices. That we're the only people who can see those portfolio posts except for your parents. So do put questions on there, or just upload what you've done and show us how you've gotten on. And have a fantastic rest of your day. Well done, Year 5.